Hey there, everyone. In this video, we're going to talk about the basic trig functions, sine, cosine, and tangent. We're going to talk about how they were defined, what they mean, and how to represent them by graphs, and how to understand them in general. All right, so let's take a look. So here we have a picture of the unit circle. Unit means that the circle's radius is 1, and you can see that from the center to this point here, that's a distance of 1. All right, and we always position the unit circle so that it's centered at the origin. That's the point 0, 0 right here. So the unit circle is a circle of radius 1 centered at the origin in the xy plane. So that's what we're looking at here. Now what we're going to do is we're going to take a point on this circle. All right, there it is, point P. All right, and what I'm also going to do is I'm going to consider the angle that that point is off of the positive x-axis. We always measure our angles counterclockwise away from this line, the positive x-axis. So you can see right now my angle here is 0 degrees. So as I change this angle, right, my point moves around the circle. As I increase my angle, the point moves around and around and around. Now, I got to point out something in this software. Angles can get bigger than 360 degrees. But the software I'm using, I cannot get it to label it bigger than 360 degrees up here. It wants to start back over at 0. So we're going to have to focus on this as our angle measurement down here. You'll see what I mean right here. Say I'm actually over 360, but it's showing my angle as if it's only 25 over here. So what this really means, how we're going to interpret this, is that this is 360 plus 25. So this is actually 385 degrees, all right? Which is what it's telling us down here. So pay attention to this for the actual angle measurement. It's just a limitation of the software we have. So we can spin that point around and around, all right? And given any angle, we have a different point positioned on the circle. Well, when we do this, we may be interested in what the coordinates of this point are. What are its x and y coordinates? That's a very natural question to ask. Well, what we need is we need a function that converts this angle here, this angle, into the x coordinate. That's going to be one function. We're going to need a function that converts this angle into its y coordinate, and then we'll have the coordinates of the point. So we need two functions, a function for the x coordinate and a function for the y. What are these functions? Well, these are the cosine and sine functions. The cosine function is defined to be the x coordinate of this point. So if you plug this angle into the cosine function, it will spit out the x coordinate of this point. So the cosine of 18 degrees will be the x coordinate of whatever this point is. We can see some basic values of the cosine function. When the angle is 0, we see the point is at the point 1, 0. So its x coordinate is 1. And so we can see that the cosine of 0 degrees, is equal to 1. As I increase the angle up to about there, 90 degrees, our point's x coordinate is now 0. And so we see that the cosine of 90 degrees is 0, the x coordinate of this point. If I push this point over here to 180 degrees, the cosine of 180 degrees is the x coordinate of this point. Now it's at -1. If I push this further, the cosine of 200 and, come on guy, there, oh, there you go. 270 degrees, cosine of this angle is 0, because the x coordinate of this point is 0. And if I push this over to here, cosine of 360 degrees is back to 1. And then the process starts over again, right? Now we can also talk about sine. We said sine was the y coordinate of the point. So sine of 0 degrees is the y coordinate of this point, which is 0. So sine of 0 is 0. Sine of 90 degrees is the y coordinate of this point, which is now 1. Sine of 90 is 1. Sine of 180 degrees is the y coordinate. It's now 0. Sine of 270 degrees is the y coordinate of this. It's -1. and sine of 360 degrees is the y-coordinate here, it's 0, and then the process starts over again. Okay, great. So we understand how sine and cosine work. They just give us the y and the x coordinates of that point determined by an angle. So when we have functions, one thing that we might want to do is graph them. All right, so let's start with the sine function. That's the one that's actually easier to see how it works. So I'm going to start drawing a graph of the sine function. So remember, the sine function is the y-coordinate of this point. Well, that's just the height of the point, right? So what I have here on the x-axis is I've labeled angles. Now I've got them marked off in radians, all right? So remember, angles can be measured in degrees or they can be measured in radians, and you can convert from degrees to radians. So we're going to have to do that. What you're going to see down here is the angle in degrees, but what we're plotting on the x-axis is that same angle in radians. So as I start increasing the angle, we're going to start plotting the sine function. All right, so here we go. Aha! There it goes. You can see it climbing up here. Notice that the value of the sine function is always the height of the point. That's because sine of the angle is the y-coordinate of the point. So they will always line up. So there we go. There it goes. There goes the graph of the sine function. Now here, the point starts going down, and so the sine function starts going down. Now I'm in the way a little bit. And as we see here, the point's going down. When the point gets to here, the y-coordinate is 0, so sine is 0. So we went back down to 0. And if I keep going, sine will keep going. Now I got to zoom out so we can see this. All right. Remember, 180 degrees is pi radians, so this makes sense. And I'm going to push the angle past 180 degrees. And we can see that the height of the sine curve is always matching the height of that point. So we can see that this is what the graph of the sine function looks like. And it goes up and down. And we said that once we pass 360 degrees, the process starts all over again. Well, you can see that happening in the graph. It goes up, it comes down, it comes back, and then the entire graph from here to here starts over again. If I keep going a little bit further here, you'll see if I look down here, the graph just repeats itself over and over and over again. The amount of distance that it takes to repeat itself, in this case 2 pi radians, remember that gets you all the way around the circle, that corresponds to 360 degrees, is called the period of this function. The period of a function is how far you have to go before a function repeats itself. Not all functions have a period because not all functions repeat themselves like this. But for functions that do, we can talk about their period, and for the sine function, its period is 2 pi. Now let's look at the cosine function. So let's unwind this and start over with the cosine function instead of the sine function. Now remember, the cosine function is going to be giving us not the y-coordinate of the point, but the x-coordinate. So we're starting at 1. So I know the cosine function is going to start up here at height 1. All right, so let's let her rip. All right, here we come. As I increase that point, this is harder to match up than the sine function. But if we look at what's happening here, the height of this graph is the x-coordinate of this point. And we see that x-coordinate of that point is getting closer and closer to 0, and that's why the graph is going down to 0. By the time we get to 90 degrees, or pi over 2, we've hit 0. Now, as I go past 90 degrees, past pi over 2 radians, the x-coordinate becomes negative. See, we're to the left of the y-axis, and so the graph dips below the x-axis. The x-coordinate is now at its minimum value of -1, so the graph is at its minimum value of -1, and so it starts coming back up. At this point, this angle here, the x-coordinate is back to 0, and so the graph has increased back to 0. And as we pass 270 degrees, the graph goes up, and the process starts over again, because we've gone once around the circle, and the circle's repetitive, right? So once you go once around, you just start over again, and that's why the graph is going to start over again. And we see that the graph has, just like the sine function, a period of 2 pi. So both the sine and the cosine function have period 2 pi. Let me graph both of them side by side. We see the sine function over here and the cosine function over here. You can see they're very similar. They're actually just shifted away from one another horizontally. They're the same graph, but shifted just a little bit. Now, there's one other trig function that's important that we can talk about, and that is called the tangent function. The tangent function gives us the ratio of y over x, where x and y are the coordinates of this point. Now, if we think about what that means, if I take a point over here, what is the ratio of y over x? Well, that's height over horizontal displacement. That's rise over run. That is the slope. It's the slope of this line segment right here. That is called the tangent of this angle. Tangent gives you the slope corresponding to this angle. So you can see here I have a positive slope, and as I push theta past 90 degrees, now I'm looking at the slope of this line segment. That's a negative slope. If I go over here, the slope is positive again. And if I go over here, the slope is negative again. So tangent is changing, positive, negative, just like the sine and cosine functions. But there's something else going on here. There's something else special going on here. We know that horizontal lines have 0 slope. So this is where the tangent is 0. So tangent of 0 is 0. But what happens when I get up to 90 degrees? Well, we know that the slopes of very steep lines are very large numbers. In fact, the steeper the line, the larger the slope. The slope goes to infinity as the line approaches a vertical line. And so when I get to 90 degrees, I have a vertical line. This is vertical, and the slope of a vertical line is undefined. So the tangent is actually undefined. The tangent increased to infinity by the time I got here. But then when I pass 90 degrees, tangent is now the slope of this, and it's no longer infinite, but it is a large negative number. So when the point gets close to the top or bottom of the circle, I have an undefined tangent, and it's close to either positive infinity or negative infinity. Let's take a look at its graph. So like we said, tangent starts at 0, and it's going to start increasing. So we should see the graph increasing coming out of here. Let's see if that's what we see. Yep, there it goes. You can ignore that letter H. I should have erased that before I made the video. As I increase my angle, look at tangent. It shoots off to infinity, just like we said it would. Now, what's going to happen next? Well, the slope's going to become negative, so tangent's going to jump down to negative numbers. And there it is. It's negative. You can see it down here. Now, as the angle gets us to here, 180 degrees, the slope becomes 0 again, and so tangent goes to 0. And as we pass that, the slope becomes positive again, and then it goes to infinity again, and then it goes back down to negative infinity, and then comes back. And so we see this is the tangent function. The tangent function looks like this. Now, it is also periodic, but what is its period? Well, this is a little bit different than the other functions. How far do I have to go before this pattern repeats itself? I only have to go to pi. Notice by the time I get to pi, the same picture starts over again. This picture here is the same as this picture here. Every pi units, I repeat, and so the period of the tangent function is pi. Okay, so there you go. 3 very important functions. The cosine function, the sine function, and the tangent function. And all they're doing is relating the angle to the coordinates of the point on the circle. That's really all they are. So I hope you found that helpful. I'll see you in the next video.